I've been building this tool lift for the last couple of weeks. I bought this planer from Dewalt, or a Dewalt planer. It's a really nice planer, thickness planer, but it's heavy. It's about 92 pounds. I say to team lift it. I'm usually out here by myself in the shop, so that's kind of a backbreaker. I have middle table and like end tables. But that's kind of a pain in the butt if you want to keep moving it back and forth. And also it's a little high, and a lot of mine are facing like a wall or where you don't have like a good 10 feet on either side of the planer to pass larger boards through. Like I got some big 10-inch boards over there, or 10 feet boards over there and stuff to pull through this thing. So it's nice to be able to pull it wherever I can take it outside. And lift it up and down and adjust the height, because a lot of times you're feeding it through kind of wherever your arms are lengthened, so you can kind of like just glide it through. So it's all steel and plywood, obviously, just plywood stages and base and the control panel. But everything's welded together. It's powered by this linear actuator. It's nice and strong. It's kind of slow, which you'll see, but it's like rated for 325 pounds, so it's plenty of weight between the steel stage and the planer itself. And it's attached on by an angle iron that I just welded to the base, and then it runs off this pulley system that I created. Pretty simple, just some aircraft cable running through a pulley down to this sleeve on the one side of the stage, and then the other one goes through this little, you can see there's a pulley right there. It runs through, there's another pulley right there. It comes down to this other sleeve. For the stage itself, it rides on these big uprights, corrugated steel. Something that I could pin while I was working on it was nice. I could kind of make sure they're both at the right level, because you have to make sure this is perfectly square when you're welding everything up, because you can't have it binding anywhere. So what I have for the stage, they're just skateboard bearings. So there's one on the top, one on the bottom, because you need that stability, because there's a little bit of a flex going up and down. It kind of shifts. So usually this one runs when it's going down, and this one's got the pressure on when it's going up. So this is just a piece. The sleeve itself is a piece of the corrugated that I kitty corner cut, so just diagonal cut, and then added some small 1/2-inch rebar or angle iron on the edges to make it a little wider, to accept floating up and down this upright. And then I just used a bolt, obviously, and I just thread locked those on there, and then welded, not great welds, and then I welded on the head with just a piece of rod over. Then the stage is all 1.5-inch angle iron with just a piece of plywood on the top, and then that's all supported. I just have the plywood resting on the top. Then on its belly face down, I used another piece of 1/2-inch angle iron with a flat bar support coming there to get your nice triangle for extra. Since it's cantilever, it would bounce too much, and these won't work properly. So I added another bearing. This one's a little bigger. You can see they're on each side, so they help smooth out the ride and keep the weight kind of like a bookshelf support of some sort. And then these uprights are just welded to the base. I've just made some small corner supports. And then the base is, again, it's the same thing as the stage up here, but with the piece of plywood underneath, and I have these nice big casters. These front ones have locking casters, so you can just step on them when you're running a machine, so it's not vibrating all over the place. And you can take it wherever you want, since they're nice big casters. And on the top, I just welded a little piece of 1-inch angle iron across to keep these nice and tight, tight, I guess, to keep them from racking and stuff. Then powering the linear actuator, I just have like a computer computer power adapter, something with a little more power to feed this, because if you have a standard 12 volt, some of them you have to match the amperages and whatnot. And then it's a double pull, double throw switch. So going up, it will hold. I don't have it plugged in right now. Going down, it doesn't hold. So I have this little wing nut that will hold it on. So you can kind of walk away from it, since it does kind of go pretty slow, which I'm okay with. Beats having to wrestle it around. So I'm just gonna plug it in here. And then it's all the way down right now, so you can see it's kind of level. So I'll just turn it on. You can see the bottom bearings moving, and then it's usually this bottom bearing on each side that moves also. The top one doesn't really touch. And it shuts off when it's at its limit, which it's at its limit for the stroke length. This actuator is a 12-inch stroke, so obviously when it's going up, it's pulling the cable down. Vice versa. To switch it up, to get it to stick, you have to switch it over and you spin that wing nut around and it drops down. For going down, I have, it will go down past the mount. After this hits, it'll keep a little more cable going out, since I had to add those supports just to beef it up a little bit. But you just kind of pay attention and turn it off whenever you're ready. It's about to hit there. You can hear the stress off of it, so it will keep going. We can just keep it running, but you see the stroke height just keeps going until right about there. Maybe. Wow. I guess there.